In the vast tapestry of human knowledge, the ancient practices of Babylonian celestial observation represent a profound intersection of empirical investigation and spiritual interpretation. This script delves into the early systematic approaches employed by Sumerian and Babylonian skywatchers, whose meticulous records laid the groundwork for what would eventually evolve into the intricate field of astrology. Thousands of years before modern scientific instruments, these ancient observers dedicated themselves to understanding the patterns of the heavens. In southern Mesopotamia, beginning around 3000 BCE, the Sumerians attentively noted the cycles of the moon, the transit of the sun through the seasons, and the erratic yet predictable movements of visible planets. Their observations served practical purposes for an agrarian society that relied on the celestial cycles to regulate critical aspects of daily life, such as planting, harvesting, and the scheduling of religious ceremonies. The rigorous documentation they achieved was not merely an exercise in curiosity, but rather an essential mechanism to counter the uncertainties imposed by the natural world. Agricultural planning and civic organization were deeply intertwined with these early astronomical endeavors. Through the careful construction of lunar calendars and the systematic recording of celestial events on clay tablets, ancient scholars encapsulated a wealth of knowledge that bridged both scientific inquiry and theological insights. Their records, ensconced in the durable medium of clay, remain a testament to an era in which observation and belief coalesced into a robust intellectual tradition. As we embark on this narrative journey, it is imperative to appreciate how these foundational practices not only shaped the destinies of ancient civilizations, but also laid the cornerstone for subsequent developments in astronomical science and astrological thought. The following sections explore these technical accomplishments with precision, drawing on multiple layers of evidence and fact-driven analysis that resonate with the rigor of modern scholarship. Deep within the arid landscapes of southern Mesopotamia, the Sumerians emerged as pioneers of celestial observation. Their approach was grounded in acute empirical observations paired with a keen intuition about the cyclical nature of astronomical events. Living amid geographical challenges that demanded precise agricultural planning, early skywatchers methodically recorded the shifting phases of the moon and the intricate path of the sun across a dynamically changing horizon. Detailed observation of the heavens revealed consistent patterns, where the moon's waxing and waning, the seasonal prominence of the sun, and the periodic appearances of visible planets provided crucial markers for timekeeping and ritualistic observances. These early observers maintained a practical perspective, meticulously correlating the celestial cycles with the rhythmic changes necessary for the cultivation of land and water management in a challenging environment. By integrating planetary and lunar cycles with their calendar systems, the Sumerians managed to devise a sophisticated timekeeping mechanism that was instrumental not only for scheduling agricultural activities, but also for regulating religious festivals and civic ceremonies. Their recording methods were both innovative and precise. The use of clay tablets to document the periodic nature of celestial events allowed for the preservation and transmission of critical astronomical data over generations. This detailed data collection was executed through systematic and repetitive observations that transformed chaotic celestial movements into a predictable sequence. The methodical capture of events, from the subtle gradations of lunar illumination to the rare but significant occurrences of celestial alignments, marked the birth of an empirical discipline that predated later formalized astrological systems. The Sumerians' observational records underscore a profound understanding of natural cycles and a pioneering spirit in scientific inquiry. It is through these scrupulously maintained archives that contemporary scholars can trace the origins of our systematic approach to understanding the mechanics of the cosmos, a testament to the Sumerians' enduring influence on astronomical science and early astrological practice. Further analysis of these ancient records reveals the Sumerians' intricate understanding of mathematical cycles and their application in calendrical calculations. The integration of observational data with basic arithmetic allowed early scholars to predict lunar eclipses and seasonal variations with notable precision. Their commitment to exactitude is evident in the recurrent motifs and standardized notations inscribed on each tablet, presenting an early model of data representation and computational recording that laid the foundation for subsequent astronomical advancements. This systematic methodology demonstrates a convergence of observation, record-keeping, and scientific reasoning. Building upon the legacy of early observational efforts, the transition to systematic record-keeping in Mesopotamia marked a crucial evolution in human thought. With the development of writing, scholars began to document celestial events with unprecedented consistency, using clay as their medium. In cities renowned for intellectual activity, such as Ur, Nippur, and Babylon, dedicated scholars meticulously recorded lunar phases, planetary positions, and solar phenomena. These clay tablets, inscribed with symbols and numerical data, represented a leap from oral traditions to a scientifically rigorous medium, ensuring that astronomical observations could be shared and refined over extended periods. The process of recording was imbued with both practical necessity and a drive for precision. Farmers, political leaders, and religious officials alike recognized that reliable records could predict seasonal changes, inform agricultural endeavors, and guide public policy. The documentation extended beyond mere descriptions. Records included intricate tables cataloging celestial positions, dates for eclipses, and periods of brightness and darkness observable in the sky. Such data, when analyzed over successive years, revealed patterns that hinted at underlying celestial mechanics. In many respects, these records laid the intellectual groundwork for predictive models and early theories of astronomical cycles. In addition to their utilitarian functions, these records carried significant epistemological weight. They stand today as testaments to the Sumerians and Babylonians' intent to impose order on the cosmos through written documentation. The careful enumeration of days and cycles can be seen as an early form of data analysis, striving to decode the language of the heavens through numbers and symbols. This systematic approach underscored a methodical mindset, one that anticipated the analytical techniques employed by later scientific disciplines. The transition from sporadic observation to comprehensive documentations signifies one of the earliest instances of a deliberate scientific methodology. It encapsulated both qualitative insights and quantitative precision, marking a pivotal moment when human curiosity transformed into structured inquiry, establishing a legacy of empirical data collection that would profoundly influence future astronomical research. Moreover, this transition is emblematic of a broader intellectual revolution that redefined the relationship between observation and documentation. The precise notation and methodical record-keeping mirror techniques that modern scientists use today. Every carefully inscribed numeral and symbol on these ancient tablets underscores a deliberate effort to quantify celestial phenomena, laying the analytical groundwork that continues to inform contemporary space sciences and astronomical research. This legacy exemplifies the timeless bridge between rigorous observation and systematic knowledge preservation indeed. With the rise of Babylon as a cultural and intellectual hub, the transition from mere observation to interpretive astrology occurred with remarkable sophistication. The Enuma Anu Enlil, a monumental compendium compiled around 1000 BCE, epitomizes the advanced state of Babylonian astrological thought. This extensive codex, comprising over 7,000 omens, systematically linked celestial events to earthly affairs with a precision that remains impressive today. The text organizes cosmic phenomena into a structured framework, where specific events, such as the alignment of prominent planets or the sudden appearance of a comet, served as harbingers for a range of terrestrial outcomes, from the success of agricultural harvests to the stability of political regimes. The rigorous methodology evident in the Enuma Anu Enlil is rooted in centuries of cumulative astronomical data and skilled observation. Babylonian priests and scribes, entrusted with the responsibility of interpreting the divine messages encoded in the heavens, relied on extensive records, painstakingly accumulated over generations. Their work was not based on speculative theories alone. It was underpinned by detailed numerical analyses, recurrent observations, and statistical correlation between observable celestial patterns and historical events. Every chart, Every table inscribed in the codex reflects an underlying assumption that the cosmos operates as a complex but orderly system, a belief that has profoundly influenced later astrological traditions across the world. This codex served multiple functions within Babylonian society. On a practical level, it provided a predictive tool, enabling ordinary citizens and rulers to anticipate natural events, plan economic activities, and mitigate potential calamities. The scientific aspect of the work is further exemplified by the methodical manner in which data was categorized and interpreted. In many instances, the Enuma Anu Enlil not only predicted immediate events, such as eclipses or planetary conjunctions, but also offered a framework for understanding longer-term patterns in nature. In this way, the Babylonians merged quantitative data with qualitative interpretation, creating an interdisciplinary system that straddled the boundaries of what we now call science and divination. Moreover, the integration of spiritual context into technical observation elevated the practice beyond mere numerology. Each celestial occurrence was imbued with the will of the gods, rendering the text a hybrid of scientific inquiry and religious doctrine. It is this dual nature, the blend of empirical data and divine interpretation, that not only defined Babylonian astrology but also set the stage for the development of later astrological systems in the Hellenistic world and beyond. The Enuma Anu Enlil's comprehensive approach laid the foundational principles that have endured, informing both historical and modern interpretations of celestial phenomena. Furthermore, the Codex's intricate categorization of omens demonstrates a high level of sophistication in early data analysis. Detailed annotations on each tablet indicate predictive probabilities and thresholds for various outcomes. This analytical precision suggests that Babylonian scholars not only observed celestial events but also engaged in complex statistical reasoning. Their work signifies an early prototype of probabilistic forecasting, highlighting an advanced understanding of the natural world's regularities that resonates with contemporary methodologies in astrophysics and data science, pushing analytical frontiers. In the realm of Babylonian celestial practice, a profound synthesis of scientific observation and spiritual symbolism emerged. The meticulous documentation of astronomical phenomena was not an isolated technical achievement. It was invariably interwoven with a belief system that assigned divine significance to every cosmic occurrence. From the synchronous patterns of planetary alignments to the subtle nuances of lunar phases, every observed event was interpreted as a manifestation of the god's will. This holistic approach affirmed that the empirical and the transcendental were not mutually exclusive, but rather complementary facets of a comprehensive worldview. Celestial bodies were perceived not simply as objects moving through the sky, but as emissaries of divine power. The moon, for instance, was closely associated with sin, symbolizing both the nurturing and the transformative aspects of the deity. Venus, with its brilliant presence at dawn and dusk, was linked with Ishtar, reflecting themes of love, war, and rebirth. These symbolic associations were rigorously codified in religious texts and astrological treatises, ensuring that the interpretation of celestial events adhered to a strict set of theological and ritualistic norms. Advanced practitioners of Babylonian astrology employed a range of techniques to integrate astronomical observations with divine prognostications. They developed numerical systems and symbolic notations that served as a universal language, bridging the gap between empirical evidence and mythological narratives. Every recorded movement of a star or planet was cross-referenced with established omens, creating a sophisticated matrix wherein quantitative data was imbued with qualitative significance. This methodological cross-pollination allowed for precise predictions while simultaneously affirming the metaphysical order dictated by the divine realm. The spiritual framework underlying Babylonian astronomy imparted an air of solemnity and purpose to every observable event. It reinforced the notion that the cosmos was a dynamic interplay of natural laws and supernatural mandates. By merging rigorous observation with divine sanction, Babylonian scholars managed to create a dual system of interpretation that not only anticipated worldly events, but also provided a deeper insight into the underlying cosmic order that governs both the physical and metaphysical realms. This intricate interrelationship between science and spirituality is emblematic of a period where the boundaries between empirical investigation and religious doctrine were fluid, enabling a legacy of thought that continues to inform modern astrological and astronomical discussions. These integrative practices underscore a sophisticated intellectual framework that combine precise empirical observation with deep spiritual symbolism. They reflect an advanced understanding of the cosmos, where astronomical data was not isolated from myth or ritual, but part of a comprehensive system of knowledge that continues to inform and inspire scholarly research today. This enduring synthesis remains central to our modern scientific heritage. Tracing the intricate evolution of Babylonian astrological practices reveals a legacy that permeates modern interpretations of celestial phenomena. The detailed records and methodical analyses developed by ancient scholars provided the foundational techniques upon which later systems were built. Their systematic approach, balancing empirical observation with symbolic interpretation, has echoed through the ages, influencing the development of the zodiac and the subsequent rise of Hellenistic astrology. This enduring impact is evident in the precision of modern astronomical instruments, which continue to depend on the same principles of observation and record-keeping. Babylonian methodologies introduced key concepts such as the segmentation of the sky into discrete sectors, early numerical systems for quantifying celestial events, and the use of standardized symbols for recording astronomical data. These innovations have left a lasting imprint not only on astrological sciences, but also on the broader field of astronomy. Through rigorous statistical analysis and fact-driven approaches, modern researchers often reference ancient tablets as early exemplars of systematic scientific inquiry. This profound influence underscores that the intellectual bedrock laid in Babylon was critical to the evolution of both cultural and scientific paradigms. The transmission of knowledge from Babylon to later civilizations is marked by continuous reinterpretation and adaptation. As astrological methods were assimilated into Greek philosophy and then integrated into Roman scholastic traditions, the core principles of Babylonian observation persisted. Modern astrological practices, while significantly refined, still incorporate the original emphasis on aligning earthly events with celestial cycles. Moreover, the analytical rigor that characterized Babylonian records can be seen as a precursor to the methodologies utilized in contemporary space sciences and computational astronomy. A careful, fact-driven analysis of these ancient practices reveals a remarkable continuity, bridging millennia of human inquiry. This comprehensive legacy is not confined to theoretical constructs, but is manifested in practical applications. The Babylonian tradition of meticulously recording and analyzing celestial phenomena laid the groundwork for predictive techniques that have evolved into modern forecasting and data analysis models. Their influence is a testament to the enduring power of systematic observation and creative interpretation in shaping our understanding of the cosmos. In essence, the legacy of Babylonian astrological thought remains a fundamental pillar in both historical and modern scientific endeavors. Furthermore, these ancient innovations continue to serve as a benchmark for modern scholars. Their legacy offers indispensable insights into the evolution of scientific methodologies and the intricate correlation between celestial phenomena and human culture, truly enduring wisdom. Reflecting on the monumental contributions of ancient Babylonian and Sumerian celestial observation, this narrative underscores how early empirical and symbolic practices forged the path for modern astronomy and astrology. The meticulous records, systematic methodologies, and profound spiritual integration not only provided predictive capabilities but also offered a paradigm of interlinked scientific and divine inquiry. This historical synthesis, derived from painstaking observations and rigorous documentation, stands as a testament to human curiosity and intellectual pursuit. The legacy of these pioneering skywatchers continues to inspire contemporary research, reminding us that the heavens have long been a source of both wonder and wisdom. The enduring impact of their work resonates in every modern instrument and analytical model, bridging the ancient past with our advanced present in an unbroken chain of cosmic understanding. This enduring legacy challenges us to expand our analytical perspectives and continually evolve our methods in the pursuit of celestial truth.